Okay, so the next question is from expansions part 4. If x cube plus y cube plus z cube is equal to 3xyz and x plus y plus z is equal to 0, then find the value of x plus y the whole square upon xy plus y plus z the whole square upon yz plus z plus x the whole square upon zx. Let's do this. Now we know that x plus y plus z is equal to 0. So what does this imply? It implies that x plus y is equal to minus z, y plus z is equal to minus x. If you keep y plus z here, x will shift there, it will become minus x, and z plus x, if you keep z plus x here, it will become minus y. So we got the value of x plus y, y plus z, and z plus x. Why did we find the value of these three terms? Because they are required here, right? So we'll substitute the value of x plus y, y plus z, and z plus x in these three fractions. So therefore x plus y the whole square upon xy plus y plus z the whole square upon yz plus z plus x the whole square upon zx is equal to, okay, x plus y is minus z, so minus z the whole square upon xy plus minus x the whole square upon yz plus minus y the whole square upon zx. Let's simplify this. Z square upon xy plus x square upon yz plus y square upon zx. The denominator is xy, yz, and zx, so we'll take LCM. So what is the LCM of xy, yz, and zx? The LCM of these three terms is xyz. So here I will multiply by z, here I will multiply by x, and here I will multiply it by y. So this will become z cube plus x cube plus y cube the whole upon x, y, z. Right, z into z, z cube, x into x square, z into z square, z cube, x into x square, x cube, y into y square, y cube. The denominator all are multiplied by z, x, and y, so x, y, z is the LCM. Now what is x cube plus y cube plus z cube? See, it is given in the question, it is 3xyz. So I will write it as 3xyz upon xyz. Gets cut and you get the answer 3. So very different question, but very important. Let's move to the next question. The next question is a plus 1 upon a is equal to m, a minus 1 upon a is equal to n. Find the relationship between m and n. Relation between m and n. Now very different question, but if you know the identities very well, then you can solve it. So to find the relationship between m and n, I ask you, do you remember any identities involving a plus 1 upon a and a minus 1 upon a? You can pause the video and check the identities which I gave you in the first video. Any identity with relationship between a plus 1 upon a and a minus 1 upon a. The identity which is required is a plus 1 upon a the whole square minus a minus 1 upon a the whole square is equal to 4. Right? So what is a plus 1 upon a? M square. Minus what is a minus 1 upon a? N square is equal to 4. M square minus n square is equal to 4. This is the required relationship between m and n. right? Next. Now next question is, you have to expand. First you need to expand 5x minus 3 bracket x plus 2 the whole square, and in this expansion you have to find two things: coefficient of x square and x, and the second thing you have to find is constant term. Okay, let us expand. 5x minus 3 bracket, what is x plus 2 the whole square? X square plus 2 into x into 2, that is 4x, plus 2 square, that is 4. I just applied a plus b the whole square here. Okay, so this will become 5x bracket x square plus 4x plus 4 minus 3 bracket x square plus 4x plus 4. So I multiplied 5x with the whole bracket here, second bracket, and minus 3 with the second bracket. Now I will expand this, so it will become 5x cube plus 20x square plus 20x minus 3x square minus 12x minus 12. Okay, so this will become 5x cube plus 20x square minus 3x square is plus 17x square plus 20x minus 12x is plus 8x, and one constant term will remain as it is because there is no other constant. See, 5x cube will not add or subtract. There is no like term of x cube, so it will remain as it is. But x square, we have two terms, so we have subtracted them. 20x minus 12x we have subtracted. Minus 12 will remain as it is, right? So therefore coefficient of x square is equal to plus 17. Coefficient of x is equal to plus 8, and constant term is equal to minus 12. Constant term is equal to minus 12, right? So this is how you solve this question. Let us go to the next question. Okay, so it has been given that AB is equal to A by B is equal to B by C, and A, B and C are non-zero. Okay, A, B, C both are all three are non-zero. They are all not equal to 0. You have to prove that A plus B plus C multiplied by A minus B plus C is equal to A square plus B square plus C square, right? So first thing, the information which is given to us is A by B is equal to B by C. So can we write it as AC is equal to B square, right? I multiplied A with C and B with B, cross multiplication, so I got AC is equal to B square. This relationship will be useful to us. Now I have to prove that this LHS is equal to this RHS. So let us start. Whenever we have to prove something, we must start with one of the side, either left hand side or right hand side. So I'll start with left hand side. Okay, so what is the left hand side? A plus B plus C and A minus B plus C. I'll just rearrange the terms here. A plus C plus B and A plus C minus B. Do you see the format over here? A plus C in both the cases is common, and then there is plus B and then there is minus B. So do you know which type is it? This is of the type A plus B into A minus B. A plus B into A minus B is product of difference, sum and difference of two terms, and it gives you a square minus b square. So this is the first term square minus this is the second term square. So what is a plus c the whole square? A square plus 2ac plus c square minus, you know what is b? B square, actually b square is ac, so I'll just write ac over here. B square is ac. Okay, no problem, no problem. I could have done the other way also. So 2ac minus ac is just ac plus c square, and what is ac again? B square. So I can do it, a square plus b square plus c square. What I could have done was I could have converted this ac into b square. So 2b square minus b square would have given me b square, but this way is also fine. Okay, next question. If the sum of two numbers is 5, now see, this is a word problem kind, and they are saying that if the sum of two numbers is 5 and the sum of their cubes is 35, find the sum of their squares. So how to convert this word problem into equation form? So first we will write, let the two numbers be a and b. Let the two numbers be a and b. Now what they are saying is, if the sum of two numbers is 5, so a plus b is equal to 5. What else? Sum of their cubes is 35. A cube plus b cube is equal to 35. Find the sum of their squares. What we have to find? A square plus b square. Okay, so for doing this we'll take a plus b is equal to 5, and we have been given a cube plus b cube is equal to 35, so we will cube a plus b is equal to 5. So cubing both sides, if we cube a plus b is equal to 5 on both the sides, we'll get a plus b the whole cube is equal to 5 cube. That is a cube plus b cube plus 3ab bracket a plus b is equal to 5 cube is 125. So what did I do here? I just applied the identity of a plus b the whole cube. Now here I know few things. What do I know? I know what is a cube plus b cube. It is 35. So just write 35 here plus 3ab into, I know a plus b is 5, just write 5 over here. So I will simplify this. 3ab into 5 is 15ab, and I will shift 35 to the right hand side. So 125 minus 35. So 15ab is equal to 125 minus 35 is 90. So AB is 90 by 15, which is 6. Now you must be wondering, I got AB, but what is the use of it? AB is the missing link which we had to find, which was required. How will we use this? So what we'll do is we have to find a square plus b square, right? So I'll take a plus b is equal to 5, and I will write squaring both sides. So a plus b the whole square is equal to 5 square. So a square plus 2ab plus b square is equal to 25, and a square plus b square plus 2 into ab. AB is 6. See, that AB which we found here it is useful here, is equal to 25. So a square plus b square is equal to 25 minus 12. 25 minus 12 is 13. (25 minus 12 is 13, right? So we got a square plus b square. Okay, now without wasting any time, in the same video I'm going to start with expansions part 5, the final part of expansion which is remaining. I'm just going to start over here. Expansions part 5. There are some formulae which are used in this part. Let us write these formulae. They are very, very useful formulae and rare formulae. So in case you see some questions in which these formulae are used, then you can use these special products for finding those answers. Let's see what are these formulae. Number 1, x plus a into x plus b into x plus c. Now you can go on and expand this. You can solve this. But better than that, you can remember the formula. The formula says that x cube, because x is 3 times, so x cube, plus a plus b plus c into x square, right? Plus ab plus bc plus ac into x plus abc. You see the pattern here? It's a beautiful pattern. X cube plus a plus b plus c x square plus ab plus bc plus ac x plus abc. Right? So just remember this one. The next one, number 2, a plus b into a square minus ab plus b square. A plus b into a square minus ab plus b square. What is it? A cube plus b cube. So a plus b into a square minus ab plus b square will give you a cube plus b cube. Third one, a minus b into a square plus ab plus b square. It will give you a cube minus b cube. And the fourth one, very important one, the fourth one I consider to be the most important one. A plus b plus c into a square plus b square plus c square minus ab minus bc minus ac gives you a cube plus b cube plus c cube minus 3abc. A plus b plus c into a square plus b square plus c square minus ab minus bc minus ac gives you a cube plus b cube plus c cube minus 3abc. Very important one. So these are the last of the identities which are going to be used in the chapter expansions. This is the last and the final part, right? Now let's take a look at one of the example. A is equal to 2, B is equal to 3, C is equal to 4. We have been given the values of A, B and C. Okay, what we need to find? We have to find the value of AB plus BC plus AC minus A square minus B square minus C square, the whole upon 3ABC minus a cube minus b cube minus c cube using a suitable identity. Now, what a normal student who is not much acquainted with this concept of algebra, that is expansions, what would that student do? That student naturally would think that let us put the values of A, B, C in the places of A, B and C and solve it. Don't do that. Never do that. You understand what I'm saying? never directly substitute the values. If you read the question, they are saying that A, B and C's values are given. You have to find the value of this fraction using suitable identity. So unless and until you use a suitable identity and simplify this fraction, you cannot directly substitute the values of A, B and C. So now it is a task to think that what is the value of AB plus BC plus AC minus A square minus B square minus C square, or the denominator which we are seeing over here, that is 3ABC minus A cube minus B cube minus C cube. Okay, so what I can see here is I can relate this fraction, the denominator of this fraction and the numerator of course, with the identity number 4, which I just told you is very useful and very important. See what I'm doing. Rather than speaking about it, if I show it to you, it will make a difference. Okay. Let me write this all over again as minus of bracket A square plus B square plus C square minus AB minus BC minus AC, the whole upon. You see what I did in the numerator? I just took out minus common, so it became A square plus B square plus C square minus AB minus BC minus AC, just like one of the brackets in identity number 4. Okay, so this is what I can see over here. What about the denominator? Even the denominator looks familiar. What if I take out minus common from the denominator? What would it become? If I take out minus common from the denominator, it would become A cube plus B cube. See, minus comes outside, and A cube plus B cube plus C cube minus 3ABC remains inside. Minus gets cut. You see, minus gets cut. Now I'm simply asking you to put the value of this RHS into this fraction, the denominator of the fraction. That is, to put the value of this RHS, that is the LHS. Just put the value. Okay, so what we are going to do is minus got cut. Here it is A square plus B square plus C square minus AB minus BC minus AC, the whole upon, in the place of this bracket, that is your RHS, I am going to write A plus B plus C bracket A square plus B square plus C square minus AB minus BC minus AC. So this whole bracket and this whole bracket will get cut, because these two are in multiplication. Numerator denominator can be simplified. So the answer will be 1 upon A plus B plus C, that is 1 upon 2 plus 3 plus 4, that is 1 upon 9. Let us check the answer. Yes, it is correct. The answer is 1 upon 9. Okay, one last question. This exercise, the kind of questions which we are going to face from part 5 will have challenging questions in them. Don't expect me to give you all ready-made answers or solve all the difficult questions for you. That doesn't make sense. You have to struggle. I can support your struggle. I can take you as far as you can go. But then in the end, if you don't learn how to get out of a problem, how to solve a problem, there is no meaning. So I'm not here to give you ready-made solution. Remember that. That's why I'm solving all the solved example which are already discussed in the textbook or the PDF which I have given you. They are there. But if I solve it for you, if I show it to you that how to do it, that gives you an insight to solve the questions from the exercise. Those are the unsolved ones. Do you understand? So that's why I'm not doing many questions from the exercise, because I want you to face challenges. Spend time with it. If you spend time with it, if you get through some questions, and if you solve them by yourself, that will give you another level of confidence. And in exams, if you come across some challenging questions, then you will be able to get out of that situation using your logic, which you are using right now for solving the exercise. That's why this task becomes very difficult at times, but I'm there to help you. Once you get stuck, I will help you. Don't worry about it. Let's look at the final question, okay, of this topic expansion. The final question is evaluate 0.6 into 0.6 into 0.6 minus 0.3 into 0.3 into 0.3 the whole upon 0.6 into 0.6 plus 0.6 into 0.3 plus 0.3 into 0.3. Now some very indigenous, intelligent students, I've seen them in past. Please don't become one of them. First hear me what they do. Don't become them, okay? Just see what I'm telling, what they have done in past. Some intelligent students, they've multiplied these things and these things and these things, and they've put the answer and they've solved actually. They think that in 9th class, in the chapter expansion, the school, the examiner, the teacher wants to test your multiplication skills. Please don't do this horrible mistake. In the second video of expansion, I had discussed that there is a question like 103 the whole square, which you have to solve using identities, that is 100 plus 3 the whole square, a plus b the whole square, and you solve it. Some students, some genius students, they actually multiply 103 by 103 and they show the multiplication and they say that I want the full marks because the answer is correct. You will get 0 marks. Please understand, we are not testing your multiplication skills here. We know that you know how to multiply, you are in class 9. Here you have to use identities. This chapter is of algebra. Don't multiply and leave the answer. Listen to this, okay? How to solve this? 0.6 into 0.6 into 0.6 is 0.6 the whole cube minus 0.3 the whole cube, the whole upon 0.6 the whole square plus 0.6 into 0.3 plus 0.3 the whole square. Okay, we'll use, okay, I'm sorry that I just wrote square here, it is cube. Okay, so we are going to use the identity which we just studied, that is a cube minus b cube. What is a cube minus b cube? A minus b bracket a square plus a b plus b square. I just expanded the numerator using a cube minus b cube. I just discussed that identity with you just 10 minutes back, right? So 0.6 the whole square plus 0.6 into 0.3 plus 0.3 the whole square. So this thing and this whole bracket gets cut. You're left with 0.6 minus 0.3, which is 0.3. Much easier, much better than doing all those multiplications. So don't do that foolish mistake which many students have done in the past. So I can just tell you that when not to make mistakes, right? So expansion topic is completely over. and we are going to see you in the next video of factorization. Solve all the examples or sums from the same topic. Okay, bye bye.